divide the coefficients by 3, and I could divide the variables both by x, right? So 3x is your greatest common factor. And what you do is you actually then do the division. Take the first term, divide by 3x, take the second term, divide by 3x, and write the binomial that you would have left. So we would have x squared plus 7 left after doing that division. Does that make sense? So I pulled out a 3x, and then I had x squared left plus 7. Because this is a quadratic, you should always double check it can't go further. Like if this had been x squared minus 4, I could have taken it further with difference of squares. But this is prime. I can't factor x squared plus 7, so you factored it fully. That's greatest common factor. So be on the lookout for that one first. Then you should always be on the lookout for the difference of squares pattern. I don't think I wrote this down yesterday, but the official formula for difference of squares is a plus b, a minus b. So whenever you have the difference, it has to be subtraction. You can take the square root of each term and you write them in parentheses, one with a plus and one with a minus. So if I was going to take the square root in part B, what would I have as my factors? Take the square root of 4x squared, and then take the square root of 25. What would you have? 2x plus 5 and 2x minus 5. And the reason that this works, they're called conjugates, they're opposite of each other. 2x times 2x gives you back your 4x squared, and negative 5 times positive 5 gives you your negative 25. And when you do FOIL, your outer terms give you negative 10x, and your inner terms give you positive 10x, and there are 0 x's in this original problem. So that's why conjugates help you get this back. And then we talked about the diamond method. So I'll just show you the diamond method for 3B, and then you can try B, C, and D down below for a minute. So you're just looking for the factors of 36, right? We wrote them in a diamond in Algebra 2. You don't have to even write the diamond down, but we're looking for the factors of 36 that add up to 12. And then we're going to write them in two different binomials. So what are the factors of 36? So 1 and 36. 6 and 6 are the ones you want. And this is actually in a perfect square trinomial box. So that's why x plus 6, x plus 6 comes out the same, because I can actually write it as a perfect square, x plus 6 squared. So take a minute by yourself if you haven't yet, and try B, C, and D down below using the diamond. They are all factorable, so you should be able to find an answer to each one. Factors here. So let's see, on B, we're looking for the factors of positive 32, but they have to add up to negative 12. So they would both have to be negative, right? So x minus 4 and x minus 8. And if you get stuck on these, what I would do is I would just start factoring 32. Like 1 times 32, 2 times 16, and then obviously 4 times 8. Are those all the other factors? That's divisible by 3 or 6. So that's it, right? So then from that list, you can be like, all right, 4 and 8, I can get to 12 that way. So make a list of all the factors if you get stuck. And then you'll know if it's prime. Okay, none of these work, so I can't do it. It would be prime. Because I might throw a trinomial that's prime, not factorable. All right, so then let's see, 48. What was that one? I need two minuses again. So what'd someone say? Yeah. So minus 8 and minus 6 gives you positive 48, and then your outer plus your inner gives you negative 14. Yep. All right, and then the last one, you're going to need what? To get negative 5, one of them will have to be positive and one of them will have to be negative. So did you put positive 5, right? Positive 5 with a negative 1, so that your inner would be that 5x, and then minus 1 gives you 4x. Did we do okay on the trinomials? These should be relatively easy now that we've reviewed them. Maybe just finding the factors is hard. That method, these 3 methods from the front page need to be like set in stone in your brain. Did you have a question? Or okay. So then the last one that might take a little bit more practice today, first of all, is identifying the correct method. That does take some practice for your eye to see what method am I supposed to use. But also this, either using the box method or the grouping method. I don't care which method you use. Did some of you say that you did use grouping last year? So I'm going to do grouping first this time. And then if you want to use the box method, I'll show you how to use the grouping items to do your box. So you basically, you rewrite the first term, 2x squared, and you rewrite the last term, 4, and it's the same thing. We need to split up this 9x the same way we would in the box. I guess we could just set them up simultaneously. So you've got your 2x squared here, and you've got your 4 down here. You still do the diamond method the same way to generate your other two terms. So we are looking for 2 times 4 is 8, and the bottom of my diamond is 9. So I'm looking for the factors of 8 that add up to 9. So that would be 8 times 1. And you just write plus 8x plus 1x plus 4. So 8x and 1x go in the box. So if you can generate the terms for the box, it's no different with generating the terms for grouping. And then obviously on the box, you find your two factors. Grouping, we're going to learn today a little bit for grouping these 4 terms on page 112, but you group together your first 2 and your second 2 items, and you do greatest common factor twice. So what's the greatest common factor for the first parenthesis? It would be 2 x's. So I can take out a 2x, and I have x plus 4 left inside this first parenthesis if I divide out the 2x. And then over here, the greatest common factor is just 1. So if I divide out a 1, I still have x plus 4 left. You have to have the same thing show up in both parentheses or it's not factorable. So I can take out the x plus 4 from each of those terms, and then I have 2x plus 1 left after I divide by the x plus 4. And you should get the same thing up here when you do the box. So you would put a 2x and an x on your box, and then x times 1 is 1x, and 2x times 4 is 8x, and 4 times 1 is 4. So see how you get the same set of factors? 2x plus 1 and x plus 4. It doesn't matter the order you write them in, so this is the same answer. And what I had said yesterday, if you don't like either of those methods, if you've got kind of small numbers, so you've got 2x squared, which is prime, plus 9x plus 4, just solve the puzzle in your head, because you know that that has to be 2x times x. The only multiples of 4, or factors of 4, could be a 4 and a 1, could be a 1 and a 4, or it could be a 2 and a 2, and just guess and check what's in those spots. So to get to 9x's, 2x will have to get multiplied by 4 to get you to 8. So it's 4 and 1. And then 1 times x is 9x. So if you're a guess and check kind of person, that could also work for you. All right, so how are these next questions different? So they all say equal to 0. So there's one extra step that you have to do after you factor. And so there are 12 questions. When you get to the back side, it says recall the quadratic formula. I'm not going to be quizzing you on the quadratic formula. So in this case, if the equation's not factorable, if you just want to write prime, that's fine. If you want to practice the quadratic formula, go for it. But prime is fine. I'm not going to have you do the quadratic formula for your test or quiz. So if it's prime, it's prime. On this page, though, before you start, you have to get 0 on the right-hand side. So on all of these, if they don't say 0 on the right-hand side, make sure you get them equal to 0 before you start. So let's just do number 1 together. Why don't we do the box method? Because this is, I can't divide out by 2. So I have 2x squared as my leading coefficient. So we'll do one more time the box method, and we'll practice solving it for 0. So 2x squared, 12 would go in the bottom. And then you're going to divide up those 11x's strategically. So I'm going to do 2 times 12 is 24. I'm looking for the factors of 24 that add up to 11. So what would my factors be? 8 times 3, right? So 8x and 3x, it doesn't matter which box you put them in. And then you're going to factor along the outside of the box. This does matter. If you put the 2x on the top, now you got to get to 3x's down here. So you've got to strategically place your 2x across from the row that it's basically the greatest common factor of. So 2x times x is 2x squared. 2x times 4 is 8x. X times 3 is 3x. And then double check that 4 times 3 is 12. So your factors are x plus 4 times 2x plus 3 equals 0. So they want you to find the x-intercepts, the solutions, which we talked about in intercept form. One of the solutions will be -4 from this parentheses, right? Because -4 makes it 0. But you have to be careful when x has a coefficient. So this is not just -3. It's -3 divided by the two x's. It's -3 halves. So x is either -4 or -3 halves. And if you didn't understand how I got -3 halves, what you're doing is you're setting your factor 2x plus 3 equal to 0 to use that zero product property to get 0, and you're solving for x. So see how you would subtract 3 to the other side, and then you would divide by 2? So -3 halves is the correct solution. So just be careful that you're actually looking, if there's a coefficient, then the answer is not just -3, like it was over here, -4. So look through, because there's different strategies here. So you've got those 4 strategies. You always want to look for your greatest common factor first. Then you want to look for that difference in squares formula, a squared minus b squared. Then you're on to the trinomial, either using just the diamond or using the box and grouping. So you've got one of those 3 things to look for. So first step is practicing which process do I use, and then make sure you solve for x at the end. And I'll have to call out how many are prime. There's at least one that's prime because I put the quadratic formula on this worksheet, but I can't remember how many of them are actually prime. So I'm going to show you the answers to the guided practice, and if you need help, let me know. I wanted to point out that on number 3, this is not considered fully factored form. You need to get to this form to get all 3 of your factors to get full credit for fully factoring the answer, and then it would have 3 solutions. And I wrote the quadratic formula on there, but you could also just write that they're prime. They're not factorable. Remember to get 0 on the right-hand side before you complete the problem. So this is really 5x squared minus 10x equals 0, which is factorable using greatest common factor. I didn't write these dark enough. 3x plus 5 and 2x minus 5. And a couple primes in there. And then on 11 and 12, you can use grouping. If you don't know how to do grouping, you can use the box method. You would put 2x squared minus 6x plus x minus 3 in your box and then do it using the box method. On number 13, before you can start, you need 0 on the right-hand side. But when you FOIL things out, your x squareds go away. So then you're just solving a linear equation for x. Hope that helped.